Good morning. In this video, we are going to see how DDL commands are used to define the table's structure. DDL commands are known as data definition language. Using DDL commands, we can tell which kind of data that we are going to store in the each column of the table so that this helps the computer to allocate memory in the memory in the storage devices. So there are many tasks that can be performed using DDL commands. We can create the tables, create columns, add columns, delete the tables, rename the table name, rename the column names, changing the size of the string, I mean the size of the varchar data type that we are going to store, and many more. So let's see. And along with that, the constraints, which means usually in a table, if there are columns, there must be there must be a column which will never have any empty values. That column should not have any empty values and it should be unique. Such kind of column is known as a primary key. So we can tell which column is going to be our primary key. We can tell which columns should not contain any null values, and which column can be unique, which column should be unique, and many more. Such kind of things are known as constraints. So in this video, in this experiment, we are going to see how the constraints are given, how the tables can be modified, renamed, added, removed, many more. All these things we are going to see in this video. So let us see what are all the tasks that can be done using DDL commands. Uh, and for to run these commands to create the tables, I am using SQL plus. You can use SQL plus command prompt. You can use maybe if there are any other platforms or other IDEs that helps you to create tables, you can use those. I am using SQL plus. So let us see what are all the tasks that are given. So the aim of this experiment is to execute data definition language commands and get the desired output. Okay, see, the title of the experiment is creating and managing tables using DDL commands. Okay, okay. See, what are all the things that we can do? Create the tables, create, drop, rename, altering. So these are all the operations that we can perform on the tables using DDL commands. So these are all the keywords that are used in DDL commands. So provided there are four tables with the data type. So they have given what is the column name and what is its data type. So with this information, we are going to create tables. We are going to create tables, describe them, and make the changes that are asked to do. Okay. So let us see what is the first task. Create user, event, venue, and ticket tables based on the given schema and describe the tables. Describe the tables. These two can be done in parallel. That is, describing the tables, we will create a table and describe it parallel, not parallelly, one after the other. So as I told you, I have used SQL plus command prompt. So this is my SQL plus command prompt, and these are all I have. So, as I have told you that I have already I have already ran all the commands and kept in my prompt, but from next time I'll make sure that everything I'll code in this video itself. I'll show you how to code and how what kind of errors may occur. But only for this time, please consider this. From next time, everything I'll do while like I'll code in front of you. I'll show you the coding part and all of it. Okay, let's see what is our first task. One second. So our first task tells us to create user, event, venue, and ticket tables based on the given schema and describe the tables. So these two we can do at one go. We can do at the same time. Like after creating the table, I'll show you or I'll describe about the table. Okay. So these are the tables. This is the schema given about each column. Excuse me. So the user ID, its data type, we can use an int data type. The user ID's data type can be an int or a number of size 10. And name usually is a string type. We have to use varchar data type. And this 25 size, I can give anything of my wish. I can give 50, I can give 25, I can give 100. Okay. And email. Email is also a string. Password is also a string. Phone number, we can use anything, but string is better to use because sometimes 91 plus is also there. So better to use varchar. So let's see how this schema is made into a table using SQL. Okay. Uh, Sorry, all these commands I have run just for a practice purpose. So from here, I have done the actual experiment. Yes. Yeah. Uh, See, I have done. I met with few errors. Okay, fine. Okay. So the syntax followed. The syntax used to create table is create table, table name, open the braces, open the round braces, and inside that you will give like this the column name and the data type of the column, first column. Then another second column name, third column name, data type, and so on. How many columns you want? For those many columns, you can do it. Okay. Okay. The first table, create table. Create is the command. Is the command. Table is the keyword. User name is the table name. User ID is the column name that I'm going to use in this table. Number 10 is the data type. And the second column name is name. Second column name is name. Its data type is varchar. Third column email. Its data type is also a varchar. Password varchar, phone varchar. And so since there are no errors, it executed successfully and you will get table created. If there are no errors, you will get table created. And the second task, which tells to describe the tables. This one, describe the tables. To describe the tables, we use something like this. The syntax. Let us see. One second. So we have created the user table and we have described about it. DESC and the table name command which we can find and computer. We can run any query or any command using without terminating it. So let us see how the event table is created. So event has the following column: the new ID, name, address, city, state, and country. As you know, name, address, city, state, and country are obviously things and they will not be stored in the database. So that's what is being done. So you how the event will be created. So here I got some mixed. It is showing me state. I'm so sorry. The second table that I need to create is event table. Event name has event ID column, name column, date, time, delivery, all the required things for an event to connect an event. So, so if you can see here, I got this tab, date, date. I gave the column name as date. And its data type is also date. So I got an error. So we cannot use like that. Since this is a keyword can never be used as a column. So in the next query, I have changed it. I have changed it to date underscore. So there is been doing any error, but here is being an error saying that I told that the time data type will be a var, but I didn't mention how much space I need to allocate it. See, it was told var, told it is a var, but it is how much space it needs. So there it will be an error. So that also will be rectified and you can see the clean code without any error. So I have done all the columns and also the data type name. And I have also described the page that we will calculate successfully and it will also it will be about the table. And it is event table. Event table also has the column name like event ID, name, date, time, venue ID, and etc. So now this command in this command sorry, we are now creating third table and sorry. We are creating a third table because when you ID, when your name, address, state, something. Same thing I have created the I have described it creatively when you then the fourth table is described in the then then I have created expect table. Expect table, sorry, expect table with this column names, ticket ID, event ID, username, seat number, price, status, everything. And then we have to create table name, ticket ID, ticket inside, student ID, is also a number type, user ID, which is also a number type, seat number, yes, some seat numbers are not present only with numbers can be A21, B26, like that. So that's why you have that. We alter the user table to add a new column age. So the age of the column name is age. We are going to add it in the user table. So let's see which command we need to use to perform the task. If it's given a command, but I'm sorry, I made a mistake. That's also a add the table name, add column, column name, the type of the column, data type of the column. But the add keyword itself understands that we are going to add a column keyword. So we need not explicitly mention the column keyword. So that is the mistake I made here. So this is so it raised an error here, showing indicating that there is an error here. So the correct command is alter table, the table name, add column name, and the data type of that column. If there are no syntaxical errors, and it will get the table created. And I have to describe the table. This is what I described. Previously, till here we had our table. Now we added the column. Next, drop the newly added column. Drop the newly added column. The new column which we had newly added column is okay? Which we had that and drop them. We will alter table, alter table, drop column A. Drop can be done with two things, with two outputs. We can drop a table, we can drop a column. So when we are using drop, we must specify whether we are setting a table or a column. So the syntax to drop a column in a table, the column of the table is alter table. Yeah, here it gave me an error because I told table. I didn't tell which table. So it shows me an error here. So in the new query, I had to add the table name, drop keyword, the column keyword, and the age column. Column keyword, drop is command. Column keyword, drop is command. Okay. Yes. So I dropped it. So it told me the table is altered successfully, and I asked it to display the new column, the new table, and the newly added page column is removed from this table. The next query is to rename the venue table to location. Okay. As the table, I'm so sorry, I am still new to this. I made a mistake. I'll make sure that the next time I'll not make these mistakes. As the table venue, okay. The mistake I made here is so I gave wrong the name of the table that I have not created. I created a venue underscore 7107, which is my register number. I have created that table, but I'm asking to alter the venue table. So give me a telling us there is no okay. No, there is no table name called venue. So still I made mistake in two more points. I didn't understand that was the mistake. So be careful while doing this. Uh, which alter table
table. It is an alter table. The table name rename to location. So, what is the syntax to alter, rename a table name? Is alter table. These are keywords. Alter table, the old table name, again the rename keyword, two keywords, and the new table name that you are going to give. That's it. So, since this command was correct, this query was correct, it told me that the table was altered. I'll describe the table after after query two, three tasks, and then I will look to the table. Okay. Then modify the size of the room. This specific task also I'll explain later. Not later, just after 7, then I'll explain you the 6th one because I forgot to execute to run query. Uh, Sorry for the inconvenience. Drop the seat number column from the ticket table. Okay. What I have to do from the ticket table column, I need to drop the column seat number. Seat number column, I need to drop. Okay. Um, alter seat. Let me tell you what mistake I have done. Modify column. Yeah. I tried to modify the column, but it was present in my table at all. That was my mistake one while performing this task. And the mistake was missing keyword. It was telling missing keyword. Modify column description. Uh, Let me check what was okay. Modify column description. Alter table modify description. Okay. Modify description was at 1000. I need to look alter table even modify column. So this to modify the column, the size of the column, we need not uh, we need not use any column keyword. It says that. So alter table name modify. I think modify itself tells we are going to change something in the column name. So we need not mention explicitly the column keyword. Directly we can use the column name. That's what it is telling. So alter table, this we have done successfully. And the next command is okay. Uh yeah, modify. Sorry. Yeah, after dropping this, I have I think okay. Uh I didn't explain the drop alter table even underscore seat number from ticket table. Yeah, this one. This one I didn't tell you. I directly went to the sixth one. Alter table name, drop column name. Okay. Alter table name. Yes. So I have dropped the seat number column from ticket table. I have told you the syntax for it. Then next what we have renamed the user ID column in the user table ID. So in the user table ID, uh, I already have, well, one second. One second. So we from the starting, even visibility. Yeah, here.
alter table, alter table is your keywords. User underscore 7107, this is my table name. Rename is the keyword, and column, that is also a keyword, and then user ID. So now we are changing the user ID, the name of the user ID to ID. So that's what I have done here. And it told me there were no syntax error. And then the next thing says next task is to modify the ticket table to add a column name, barcode with a data type of varchar 50. Modify the ticket table with a data type of varchar 50. Okay, modify. Modify. Okay. I told you that I have described all this table. Few tasks later, so this is what I have done. So do you remember we named venue table to location table, and then in the event table we changed the size of the description. In the ticket table, we in the ticket table now we are going to add the barcode. Add barcode column. Alter table ticket ID. Add barcode. This is the name of the column, and this is the data type of that column. It has add. It was added. Okay. Barcode. Yes. And then next user. In user, what we did? We had initially we had uh, initially we had user ID. See this user ID that we changed into ID. That this one, ID. Okay. And next, what do we have? Next, we have to modify the ticket table to add a column named. I think that also we have done. Barcode. That also we have done. Then the tenth one. Modify the name column of the venue table to increase the maximum length to varchar to 300. That also we are gonna do. I have already ran that query. Okay. Yeah. This is still here. Alter table location and no, yeah. Alter table. Which column they told? They mentioned here venue column, but we changed the venue column to location venue table to location table. So I used here the location table. Modify name. We are just modifying. We are not adding a new column. We are not renaming the column. We are just modifying the data type of that column. So that's what we have done here. And I have described it. See, you can see that which is this location, right? See, it got modified with 300. Initially, which is this, the venue. The venue's size was 25. We changed the size, we maximized it to 300. And then, so now we finished uh, all the DDL, I mean, not all the DDL commands, the altering the table, adding new columns. So now our 11th task is to write an SQL query to create a table named students with the following structure. Okay, I told you right. We can use constraints uh, while creating tables. Primary key means all the values of this column must be unique. So we have 4 columns, and with the see, not null. Not null is also a constraint. Being a primary key, a column being primary key, making a column primary key is a constraint. And this is also a constant. This is a check constant. This the age must be between 18 and 25 is a checking constant. It will check the value. If the given value is only between 18 and 25, it will accept it, or else it will not accept into that particular cell. Okay, now let's see how I have created. See this one. Create table, student ID, constraint. This is the keyword constraint. EQ1. This is the variable name. And primary key, name. Okay, that is a primary. I made it a primary key. Then name, that is of varchar data type, and its constraint is it should not be null. Um, uh, Name students underscore. So I have created this for some uh, like a demo thing whether it is running properly or not. To check whether it is running properly, I have made this. So this is the uh, actual code for to execute this to create this table. This is the actual table. Query: create table students underscore 7107 student ID and this and all I have told you. Primary key name and age is of type int, and it is a checking thing. Age, I need to check that age must be between 18 and 25. So I used this, but that is wrong. I'll tell you how to rectify it. And email is a varchar, and it must be unique. Obviously, the email must be unique. So in the next query, uh, I have rectified my error that check age between 18 and 25. Since SQL is a structured query English language, actually before it was named as an English language because the commands are so understandable, so readable, so human readable in English. They are just present in English. So the simple English is enough to run SQL queries. So that's what I have understood here between 18 and 25. And so that involved. So now then I asked you to describe the student's table. This is what it gave me. Uh, why I didn't give that student ID should be a not null. But since I told it is a primary key, the system itself made it a not null. Since primary key column can never have empty cells. Okay. Then 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 we are asked to write an SQL query to create a table named department with the following structure. So three column names where the department ID is a primary key and department name has some character length and it should not be null, and the location column name has also some length. Okay. Uh, Table department ID. By mistake, I have given here department. Like we are asked to what reasons this is a college experiment. We are asked to do uh, with our register number, like the underscore and register number. So in the next command, I have told to rename the table name. So the yes, the department table with three column names. See, I made the department ID column as the primary key and department name, which must not be. I constrained it that no row within this column shouldn't be empty. So that's what not null says uh, to the SQL database. So that is while user is entering, he shouldn't leave this column as empty. then location with its size. Yeah, and I have created it, I have displayed it, and then I created the see with how many errors I have created this employees, the third table in which constraints are mentioned with these many errors. Okay, let me see. Okay, this is department and this is employees. Okay. Employees, employees. One second. Okay. Uh, Employees. Write an SQL query to create a table named employees with the following constraints. It has five columns. Employee ID, employee's first name, last name, employee's salary, which department he belongs to. But see, employee ID is a primary key. First name must not be null. Last name is not so constrained, but just the length. Salary. mm, Salary must be greater than or equal to 3,000. And department ID, see this department ID where we have created in the department table. So we are taking that department tables, department ID column and fixing it in the employees column. Because this is a common thing that we do in SQL. This is called a relation between the tables. So there is a department and there are employees. Employees. One department will have many employees, and one employee belongs to only one department. Okay, right? So this is a if we go from department to employees, it will be many ones because a department has many employees, but an employee should be only in one department. He can't go in other department. Just like in our college department, ECE faculty should teach only ECE. Should be there only in the ECE department. Same like that. One employee, one department. That's it. Okay. So, so what we are going to do? We are using the primary key. See, we have done integer. Okay, department ID is of type integer and it is a foreign key. When a normal column becomes a foreign key, when it is being taken from the another table. But in another table, this key must be a primary key. Only then it becomes a foreign key here. Yes, this became a foreign key now. Now, department ID became a foreign key in which table? In employees table. Yes. Uh, yeah. So we gave this much department ID, integer, foreign key. Will the will the uh, will the will the computer understand from which table we are taking this department ID? No, it won't understand. So what we are telling referencing. So we are referencing departments, depart departments tables, department ID. You understood? We are referring this. We are referring computer. We are telling the computer to go and refer the department table, the department ID which is present in the department table. That's it. And so thus we made the department ID as a primary key in employees table by taking it from the department table. So this is how relations are made in the database because this is a relational database management system. So yeah, thank you. Thank you so much.